Welcome back to the Ultimate Zig course. I know I already have a Zig course on the channel, but as you may know, ADHD mixed with OCPD doesn't exactly let you continue something you started a long time ago. Of course, I won't delete the old videos. I think they're still very useful for anyone learning programming for the first time. But let's be honest, I didn't really talk much about Zig itself, mainly because the course was never completed. Anyway, shall we try again? Wait, before we continue, we need to agree on a few rules. Firstly, this course is about Zig, not about learning programming. I'll assume you're already a programmer. Secondly, episodes won't go over 3 minutes, so I can stay consistent and not repeat the same mistake again. Third, I'll focus on the content itself, not on showing off my editing or animation skills.
Which language usually wins?
Zig, I think right now.
Zig is known for being fast, but in 2026, we already have a lot of fast languages. Rust, Go, and even C and C++ have become much faster than they used to be. So, is Zig fast? Absolutely. In many cases, it's faster than C. But speed alone isn't enough. The real question is, do you actually trust what your code is doing? Let me show you an example. In languages like C++, D, and Rust, this code hides a lot of things. Firstly, the hidden control flow. In D language, the expression C.D might actually be in property function, which means a hidden function call. In C++, D, and Rust, the plus operator can be overloaded, so that's another hidden function call. In C++, D, and Go, the foo function might throw an exception, or panic in Go, which can completely prevent the bar function from running. Secondly, the hidden allocations. In Go, defer allocates memory on the function local stack, and it can fail with out of memory. In C++, coroutines allocate heap memory. In Rust, many standard library APIs panic if memory allocation fails. And the problem? All of this is hidden. There's no way to know just by reading the code. This isn't a feature. It's a problem for readability, maintainability, and reusability. But for Zig, it takes a different approach. If we try the same first example, we will find that Zig guarantees exactly what you see. It calls foo, then it calls bar. Nothing more, nothing less. And you don't even need to know the types. How? Well, no operator overloading. Plus means addition, not a hidden function. No property functions. Function calls always show parentheses. No hidden exceptions. Errors are returned, not thrown. You'll see try or catch when errors are possible. No hidden allocations. Allocations need explicit allocator parameter. So, the golden rule is, what you see is what you get, no surprises. Is Zig easy to learn? Well, honestly, no. The syntax isn't the most beginner-friendly. The naming conventions could be better, and mostly you'll write more code than you would in other languages. But here's the thing, that's intentional. Zig gives you complete control, total transparency, and no hidden behavior. And about that complexity, well, I think this is the price of working at this level. Well, we've got about 10 seconds left to hit 3 minutes. Use that time to leave a comment. It'll motivate me to make the next episode about the Zig compiler. See you next time.